G'day, it's Matt from Krank Engineering, back with another video in the basic electronics series. And so I just want to talk a little bit about resistance and shorts, which is really low resistance, and how that affects your motorcycle, which is a pretty common problem with the old bikes. So let's get right into it. So I've gone back and recreated one of our earlier series circuits, and pretty simple again. So batteries, light globe, switch, back to the battery. So when the switch is on, the light is on. And a common fault with an old bike is, well, a light doesn't work, or a circuit doesn't work, or an indicator doesn't work, or something doesn't work. And when you've got an old bike and things have been rattling around for a few years, obviously what can happen is a wire can be rubbing somewhere and rub through the insulation, which is there to protect the conductor, can rub through on a metal part, and then it can hit the frame or some other part that's connected to the negative terminal of the battery, and it creates a short circuit or a short to ground. And what that really means in this particular example is we're creating a very low resistance path in parallel to our light globe between the positive and the negative terminal of the battery. Now remember, when we talked about parallel circuits, we said the electricity is going to get to this point and it's going to make a choice, and whatever's the easiest path or the path of least resistance, well, that's what it's going to take. So in this case, let's use my test lead and connect across from here. So if we had a short to ground, and ground's a negative, right? What's going to happen here? The light goes out. So we've created a very low resistance path with this wire between positive and negative, and the electricity is not going to go through the globe because it's too hard to get through there. So it's going to choose to go down the short circuit. So this is pretty common on an old bike. Well, why isn't my light switch is on, but why isn't the light working? Well, in this case, you've got to start testing points on your circuit and find out, where did your voltage go? So assuming your batteries are good and your globes are good, then this is the reason why you might use a multimeter to start testing what's going on. So in this case, I'm going to put my negative terminal of my multimeter back on the battery. And first thing I'm going to do is I'm going to check my battery voltage. And I've still got, let's take all these other connectors off. I've still got 2.6 or so volts. Now this batteries are going flat. Yeah, we started in the first video with 3 point something, 6. We're down to 2.6 volts. So whatever the number is, I know I've got 2.6 volts or 2.7 volts there. I know I've got 2.7 volts there, and that should make sense because if this was a wire, these 2 points are connected with a really low resistance wire, so the voltage should be the same here. Haven't put any volts through my light globe yet, or any current through here, so it's the same. It's not lit up yet. So if I've created a very low resistance connection, then I'm going to get to this point here. I've got no volts, basically none. That's millivolts, 215 millivolts. That's a quarter of a volt. Same thing here. So I've got very, very, very low voltage here because it's created a short circuit in the system. So my next job is I'm going to be looking at this circuit on my motorbike and trying to figure out, where did the voltage go. So this is where you've got to start tracking your wires back, making sure something's not rubbed through and touching the frame, or rubbed through and touching another wire, or something like that. So typical problem. You get better at it with time, obviously, but you've really just got to go and start looking for what happened to your voltage. So a globe has got a little a filament in it, and it's just a little wire filament. Let's see if we can see it on the camera. Probably not too well. Anyone who's looked at a light globe will know what it looks like. So there's a very small wire connecting those 2 points in there, and that's a very small wire. It's got high resistance, and it's got to try and force all that current through that tiny little wire, so it gets really hot. That's a high resistance there compared to just a wire between terminals. So this is a higher resistance than the wire. So if you have a short, the electricity is going to choose to go through the wire rather than go through the globe. Okay, that's a very quick and dirty introduction to resistance and short circuits and how they might apply to your motorbike. If you've got any questions, send me an email or get on the Facebook page or put it in the comments below, and we'll see if we can help you out. Other than that, thanks for watching. Cheers.